Hi students, this is Mr. Yao. In this lesson, we're going to continue to learn more about arithmetic sequence. In the last lesson, we have learned about the recursive formula, so let's quickly go over these again. Prior knowledge. Use the recursive formula which is given there, a sub 1 equals 10, a sub n equals a sub n minus 1 minus 5. First is asking you to list the first four terms. So, a sub 1 equals 10, a sub 2, well, because this means whatever term you're trying to get, you need to use the previous term minus 5. So it's going to be 10 minus 5, which is 5. A sub 3 is going to be the previous term, which is 5, then minus 5, which is 0. And a sub 4 is going to be the previous term, which is 0, minus 5, and that's going to be negative 5. And then it's asking you to find a of a sub 20. We're going to continue. A sub 5, it's negative 5 subtract 5, which is negative 10. A sub 6 is negative 15. A sub 7 is negative 20. A sub 8 is negative 25. And a sub 9 is negative 30. A sub 10 is negative 35. A sub 11 is negative 40. A sub 12 is negative 45. A sub 13 is negative 55. A sub 14 is negative 60. A sub 15 is negative 65. A sub 16 is negative 70. A sub 17 is negative 75. A sub 18 is negative 80. And then we continue. A sub 19 is negative 85. And finally, a sub 20 is negative 90. There you go. So that's how we can use the recursive formula to find a sub 20, which is quite a process. So you may have noticed that recursive formula are a bit of a hassle because we have to get all of the terms in order to find the one we need. So if you actually want to find the 50th term, you have to get the other 49 terms first, which is not very efficient. So let's try to use a more direct way to find the term that we want. So a bit of an exploration. Please pause here and try to answer these few questions. Hopefully you have tried. Let's have a look. So here's the sequence. The d, which is the common difference, is the number in between them. So in order to get from 4 to 7 or 7 to 10, 10 to 13, you're going to need to add 3. So d is 3. Next question is, how many d's are there between a sub 1 and a sub 2? Well, a sub 1 is 4, a sub 2 is 7, so there's just one difference. So 1. How many differences are there between a sub 1 and a sub 3? So this is a sub 3. And if we keep adding the d, there are 2 of them. And then if we're trying to get to a sub 4, that's going to be 3 of them. So without counting, you may have noticed when you try to get to a sub 2, is 1 gap. When you try to get to a sub 3 is 2. When you try to get to a sub 4 is 3. So when you try to get to a sub 199, it's going to be 198 common differences or gaps. So the conclusion is, if we're trying to get to the nth term, we're going to need to take the first term and add n minus 1 of the common differences. And that is the explicit formula. So the explicit formula for arithmetic sequence is you're going to take the first term, then add n minus 1 of the differences. There you go. That's the formula. A sub n equals a sub 1 plus n minus 1 in parentheses times d. Now let's get to the examples and let's write the explicit formula. So let me write it on the top. A sub n is a sub 1, the first term, plus n minus 1 of the common differences. So a sub n equals a sub 1 is 2 plus n minus 1 times d is 5. Let's simplify. We do need to distribute the 5 into the parentheses. So we got 2 plus 5n minus 5 simplifies to be 5n minus 3. Next, b sub n is b sub 1 is 10 plus n minus 1 times negative 11. We need to distribute the negative 11. So we got 10 minus 11n, that's a negative 1 times negative 11, so it's a plus 11. We got negative 11n plus 21. Next, a sub 1 is 4 based on the information given. And you can see 4, 7, 10, 13. So d is a 3. Then we can write the explicit formula. A sub n equals the first term, which is 4, plus n minus 1 times the d, which is 3. Let's distribute the 3. So we got 4 plus 3n minus 3, which is 3n plus 1. Next, a sub 1 is 55. And from 55 to 49, 49 to 43, 43 to 37, D is a negative 6. So A sub n equals 55 plus n minus 1 times a negative 6. Make sure to distribute a negative 6. We got 55 minus 6n. That's a negative 1 times a negative 6, so plus 6, which is a negative 6n plus 61. Let me point out a few things, one thing about these formulas. You may have noticed in the first example, D is 5, and where do we see D in the formula? It's right before the n. In the second one, D is negative 11 in the formula, right before the n. In the third one, D is 3, right before the n. In the fourth one, D is negative 6, right before the n. But the number inside the formula may not actually be your first term, since you kind of have to backtrack one, because there's this like 1 extra, the negative 1 times whatever the common difference is. So it's like a sub 0 if you actually look at that number. So you can't just use the formula to get a sub 1, but definitely this number in front of the n is your D, which should make sense because D is the common difference, which is the change all the time. So something else I want to point out, you have learned about y equals mx plus b. Let's make a quick comparison. You will see m is the slope, which is the change, and then here the d is the change. So the slope is in front of the x, and then here the change is in front of the n. So arithmetic sequence is kind of like linear function. The nice thing about the explicit formula is that you can get any term you want by plugging in the index. So let's say you want the 51st term, you just plug in 51, and if you want the 97th term, you just plug in 97. Let's see some examples. A sub 1 is 13, D is 7, is asking you to use the explicit formula to find the first 4 terms. So let's find the explicit formula first. A sub n is A sub 1 is 13, so plus n minus 1 times 7. Distribute the 7. We got 13 plus 7n minus 7 simplifies to be 7n plus 6. Now we can find the first 4 terms. A sub 1 is already there. And A sub 2, well, just to show you, you don't have to depend on the first term, so let's actually find A sub 4 first. So A sub 4, this 4 basically is in place of the n, just like when you're doing, say, like f of 4, you're going to replace the 4, you're going to replace the x with a 4. Same thing here, you're going to replace the n with a 4. So 7 times 4 plus 6, which is 34. There we go. That's how you can directly find any term you want. A sub 3 will be 7 times 3 plus 6, which is 24. Oh, sorry, not 24, 27. And then A sub 2 is 2 times 7 times 2 plus 6, which is 20. There you go. That's example 5. Now try example 6. Okay, let's have a look. First, find the formula. B sub n is the first term, which is 4, plus n minus 1 times negative 9. Distribute the negative 9. We got 4 minus 9n. Negative 1 times negative 9 is a plus 9, so we got negative 9n plus 13. B sub 1 is already given. B sub 2, negative 9 times 2 plus 13 is a negative 18 plus 13, so it's a negative 5. B sub 3, negative 9 times 3 plus 13, so it's negative 27 plus 13, which is negative 14. And B sub 4, which is negative 9 times 4, which is negative 36 plus 13, which is negative 23. There you go. That's example 6. Moving on. Now it's asking you to find specific term. But you are given the formula. You're given the sequence. You can easily identify the first term and the common difference so that you can actually write the explicit formula. So A sub 1 is 7. The common difference from 7 to 3, 3 to negative 1, negative 1 to negative 5 is subtracting 4. So the D is negative 4. Now we can write the formula. A sub n equals 7 plus n minus 1 times negative 4. Distribute. 7 minus 4n plus 4 simplifies to be negative 4n plus 11. Now it's asking you to find A sub 102. You can totally choose to use the recursive formula. That means you need to find the previous 101 terms. So instead, explicit formula is for sure faster. a sub 102 is negative 4 times 102 plus 11. So it's negative 408 plus 11, which is negative 397. That's example 7. You can pause here and try example 8. So now let's have a look. A sub 1 is 5. From 5 to 11, 11 to 17, 17 to 23, D is 6. A sub n is 5 plus n minus 1 times 6, distribute. We got 5 plus 6n minus 6, which simplifies to be 6n minus 1. A sub 35, let's plug in 35. 6 times 35 minus 1, which is 210, minus 1, which is 209. There you go. That's example 8. 2 more examples. Now we have learned about recursive formula and also the explicit formula. So we're going to kind of exchange between them. Let me write the formulas down first. Recursive. You have to list a sub 1, whatever a sub 1 is. And then a sub n is a sub n minus 1 plus b. Okay, that's recursive. Then we have explicit. A sub n is a sub 1 plus n minus 1 times d. Of course, after you simplify, what's easy to identify in explicit formula is the d. And what's easy to identify in the recursive formula is a sub 1 for sure, and a d is also just on the back. So we can actually use these information to write the other formula. So let's have a look. Example 9, you're given a sub 1, which is negative 7. You're also given the second part of the recursive formula, so this number you see right after the a sub n minus 1, that's your d. So you're given a sub 1, you're given the d, we can easily write the explicit formula. It's the first term plus n minus 1 times the common difference. So distribute the negative 7, we got negative 7 minus 7n, negative 1 times negative 7, plus 7. Negative 7, positive 7, they're gone, so simplifies to be negative 7n. A sub n equals negative 7n. That's your explicit formula. That's number 9. Number 10. A sub n equals 9n minus 15. So you can easily identify the number in front of your n, that's your d, so d is 9. Well, but for the recursive formula, we also need a sub 1. But in order to find any term using the explicit formula, we just plug in the number. So a sub 1 is going to be 9 times 1 minus 15. One big mistake to avoid is this number in the explicit formula, that's not your a sub 1. That's more like your a sub 0. Okay, so it's actually 9 times 1 minus 15, which is negative 6. Let's write the recursive formula. A sub 1 equals negative 6. A sub n equals a sub n minus 1 plus 9. There you go. That's the last example. And then there's one extra question, exploration question. You can choose to try it. We're going to talk about that one in the next lesson. So that is everything for this lesson. Thank you.